All right, so in this video, we're going to kind of be reviewing systems of equations and the different ways that we can solve them, but then also knowing when to use each one. It really doesn't matter when you're solving a system which method you use, but there will be times when it'll be easier to use one method as opposed to the other two. So, first thing I want to go over is, first of all, what were those methods that we have discussed earlier on in this chapter? So the first one we talked about was graphing, okay? We said that you could graph both equations, and what you were looking for was the point of intersection. Okay, wherever those two lines intersected, that was your solution to that system. Then we looked at the substitution method, okay? And we talked about how substitution is the same thing as replacing something. So we replaced what x or y equaled into the other equation. Okay, and I think for the most part, this might have been the most difficult one of the three to use. But if you use it in the right context, it makes it a lot easier and a lot less steps that you need to do to solve it. And then last and most recently, we talked about the elimination method. Okay, eliminate means to get rid of. So this was where you were trying to get either the x's or the y's to cancel out. Okay, so these were the three methods that we used, that we discussed for solving systems of equations. So we're going to go through and just look at each one separately and when it's going to be easiest to use that method. So first, let's look at graphing. Okay, you want to use graphing when both equations are solved for y. That means they're in slope-intercept form. That is the easiest form an equation can be in to graph, and if both of them are in that form, graph it, find where they intersect, and you're done. It's extremely simple. Now, so here's an example. I have y equals 3x minus 1, and y equals 1/2 x plus 2. Okay, so remember, to graph these two equations, the very first thing I want to pick out is what is my slope and what is my y-intercept on each equation. So on this first one, your slope, remember, that is your number directly in front of the x, so the 3. And remember, we want it to be a fraction so we can do rise over run. So this means we're going to rise 3 and run 1 from point to point. Your y-intercept was then that other number that was tagging along, so in this case, a -1. So keep in mind, whenever you're graphing, you always plot the y-intercept first, so I would come down to -1, put a dot, and then use your slope to get to the next point. So I would rise 3 and run 1. And there's my line, rise 3, run 1. And you could keep doing this over and over again. And then I'm going to just do my best to kind of connect these as straight as I can. And then I'm going to graph the other one. So on this second equation, my slope is 1/2, because that's the number right in front of the x. My y-intercept is a +2. So whenever I go to plot this, I have my y-intercept at 2. And then slope is rise over run. So I'm going to rise 1 and run 2. Rise 1 and run 2. And here's our line. And remember, what you were looking for is where they intersect. Now on this one, I'm not actually going to write the ordered pair because it doesn't fall directly at a crosshairs, but whatever that ordered pair would be your solution to the system. So again, with graphing, if both of your equations are solved for y, you want to graph them. It's the easiest way to solve that. Okay, Now moving on to substitution. Okay, remember this is where you're going to replace something in an equation. So you want to use this equation use this method, I guess, when one equation is solved for either x or y, doesn't matter, and the other one is not. So if you look at this example right here, we have x equals 2y minus 1 and 3x plus 4y equals 2. So the first thing I notice is that this first equation tells me what x equals. The second one doesn't tell me anything really. Okay, so in order to solve this, what we're going to do is I'm going to take what x equals. X is 2y minus 1. And I'm just going to replace that. I'm going to substitute it in for the x. Okay, so I have 3, but instead of the x, I'm going to put 2y minus 1 and then finish out the equation. Plus 4y equals 2. And then I simply solve it. Distributive property. So we have 6y minus 3 plus 4y equals 2. I combine my like terms. 6y plus 4y is 10y. I still have the minus 3 there. Equals 2. I need to add 3. So 10y equals 5, and then I divide by 10. So you get y equals, and if I simplify this, I get 1/2. Now, if y is 1/2, I don't just want to know what y is, I need to also know what x is. So now I'm going to take this 1/2, and I'm going to plug it into either equation. It doesn't matter which one. I usually like to plug it into the one that's a little more simple. Okay, and that would probably be my first one. So here's my equation for the first equation they gave me. X equals 2y minus 1. So what I'm going to do now is I'm going to take this 1/2 because that is what y equals, and now I'm going to plug it in right where the y is. So I have x equals 2, but now instead of the y, I'm going to put 1/2. So 2 times 1/2 minus 1. And then solve. Well, 2 times 1/2 is 1, minus 1, and x equals 0. So again, your answer is always going to be an ordered pair. And remember, it always goes x and then y. So 0, 1/2 would be where these two would intersect if you were to graph them. All right, lastly, we're going to look at the elimination method. This was the one we most recently went over. Okay, and this is going to be easy to use when either the x's or the y's can be canceled out. Now, keep in mind, it may not, if they already cancel out the way it is, it makes it real nice, real easy. But it won't always happen like that. So what I want to notice is, first of all, neither one of these equations are solved for y. So graphing it would be a little more work. You could do it, but it would be a little more work. For substitution, neither one of these equations are solved for x or y. So it would make a lot more work to use the substitution to solve one of them and plug it in. Elimination, I'm going to look to see if anything cancels. 2x, 3x. Those are not opposites. They're not going to cancel. Negative 3y, positive 6y. Well, as they are, they're not going to cancel out. But what I do notice is that one is negative and one is positive. And that's going to help a lot. I also notice that 3 will go into 6. So it'll make it really easy for me to change this equation so that it will cancel out. So my goal here is I want to take this top equation and I want to change this minus 3y so that it says minus 6y, and then it will cancel out. Well, in order to make that a 6, I have to multiply the entire equation by 2. So here's what I get. 2 times 2x is 4x. 2 times a negative 3y is negative 6y. And 2 times 2 is 4. The bottom equation, I don't need to change at all. And now I can solve it. So remember, we just add these two together. 4x plus 3x is 7x. Negative 6y plus 6y cancels. 4 plus 4 is 8. And then divide by 7, and you get x equals 8/7. And I'll just leave it like that. Okay? And then we would just need to plug it in to one of these equations to figure out what y is. Okay? So if I take 8/7 and let's say I plug it into the bottom one, I would have 3 times 8/7 plus 6y equals 4. Well, 3 is 3/1, so if I multiply straight across, I get 24/7 plus 6y equals 4. I would subtract 24/7 on each side. You have 6y equals, well, I know 24/7. Well, 7 goes into 24 3 times. That puts me at 21, so I would have 3 left over. So 4 minus 3 and 3/7 would give you 4/7. And I promise nothing's going to be this nasty looking. And then I divide by 6. Divide by 6, which is 6/1. Okay, and once I do KFC, you keep the first, you flip the second, and you multiply. So you get 4/42, which can be reduced. Divide them both by 2, and you get 2/21. Okay, so that one was a little nasty with all the fractions, but our final answer would be 8/7 to 21st. Okay, and usually if you're going to do that, you're not going to have anything that's going to work out that with all the fractions. Okay, but your goal with elimination is to get the x's or the y's to cancel out, and it doesn't matter which one. Now, like I said in the beginning, it does not matter which one of these 3 methods you use, whether it's graphing, substitution, or elimination, but it does make it easier for any one of them depending on how the equations look and how the problem is set up. So just keep that in mind as you work through these.